we're going to be reviewing concepts from Module 1 and Module 2 for our midterm exam. So we're going to start with Module 1, absolute value equations and inequalities. So anytime you're solving an absolute value equation, you always want to make sure you isolate the absolute value first. So in A, we're looking at the absolute value of x minus 5 equals 5. Anytime you solve an absolute value equation, there are always two solutions. So the first solution is when x minus 5 can equal 5. But since the absolute value of 5 equals 5 and the absolute value of negative 5 equals 5, we also have to solve the equation for when x minus 5 equals negative 5. So if we solve our first equation, x minus 5 equals 5, we're going to add 5 to both sides, and we're going to get that x equals 10 as one of our solutions. When we solve the second equation, we're still going to add 5 to both sides, but this time we're going to get that x equals 0. In B, we're looking at 3 times the absolute value of 3x plus 4 plus 1 equals negative 8. Typically, anytime we have an absolute value equation equal to a negative, we would say no solution. But first we have to isolate the absolute value. Because if I isolate the absolute value, it may not end up still equaling negative. So the first thing we want to do is subtract 1 from both sides. So we have 3 times the absolute value of 3x plus 4 equals negative 9. Then we're going to divide both sides by 3. So we end up with the absolute value of 3x plus 4 equals negative 3. Now that we've isolated the absolute value, we see that it's still equal to a negative number. And because it's still equal to a negative number after we've isolated it, there is no solution. In C, we have 2 times the absolute value of 2x plus 4 equals 20. Again, this is one of the cases where we want to isolate the absolute value first. We cannot distribute a number into an absolute value. So my first step is going to be to divide both sides by 2. So we have the absolute value of 2x plus 4 equals 10. Now that we've isolated the absolute value, it's still equal to a positive, so we're allowed to solve. So my first equation is going to be when 2x plus 4 equals 10. The second equation is going to be when 2x plus 4 equals negative 10. In the first equation, we're going to subtract 4 from both sides. So we get 2x equals 6. Then we're going to divide both sides by 2. And we're going to get x equals 3. Our second equation, we're still going to subtract 4 from both sides, but we end up with 2x equals negative 14, and when we divide both sides by 2, we end up with x equals negative 7. Next, we're going to look at solving regular inequalities, and we're going to write our answer in interval notation. When we solve an inequality, we get x by itself, and typically we get x on the left side of the inequality. In A, we're looking at x plus 1 is less than 7. So in order to solve that inequality for x, we're going to subtract 1 from both sides. So we end up with x is less than 6. When you're writing interval notation for an inequality, anything that is strictly greater than or less than is going to have parentheses. So that means if I'm writing the solution for everything less than 6, I'm going to start with negative infinity, and then I'm going to end with 6, and I'm going to put a parenthesis with it. B, we have 3x plus 5 is greater than or equal to 4x plus 11. So we're still going to x by itself, but I want to keep x on the left side of the inequality. So I'm going to subtract 4x from both sides. So we have negative x plus 5 is greater than or equal to 11. Next, I'm going to subtract 5 from both sides. So we end up with negative x is greater than or equal to 11. Can't have a negative in front of x, so my last step is going to divide both sides by negative 1. anytime you multiply or divide by a negative, you have to flip the inequality. So that means I'm going to get x less than or equal to negative 6. This should say 6. So similar to A, where we had x less than 6, for x less than or equal to negative 6, anytime you have a greater than or equal to or a less than or equal to, you're going to have brackets for your interval. So I'm going to have parenthesis negative infinity, comma, negative 6, and I'm going to put a bracket with the negative 6. Anytime you have an infinity or a negative infinity, you always have to put parentheses with it. The last problem we're going to look at is negative 9 less than or equal to 4x plus 3 less than 19. This would be a compound inequality. So anything I do to isolate x in the middle, I have to do to both ends of my inequality. So the first thing I want to do is subtract 3 from everything. So we're going to end up with negative 12 is less than or equal to 4x is less than 16. To finish getting x by itself, we're going to divide everything by 4. So I end up with the solution, negative 3 is less than or equal to x is less than 4. Anytime you have a compound inequality, the numbers that are going to go in your interval are on the numbers at each end of your inequality. So I'm going to have negative 3, comma, 4 in my interval. Now I just have to decide if I get a parenthesis or a bracket with each number. So because on the left side it says x greater than or equal to negative 3, it has the equal to, I'm going to put a bracket. And x is strictly less than 4, which means I'm going to put a parenthesis with a 4. You can mix parentheses and brackets for compound inequalities. You can also do it for the regular inequalities like a and b. The last thing we're going to look at is solving absolute value inequalities. There are two different types of absolute value inequalities. It's if the absolute value of a is if the absolute value of x is less than a value a, or if the absolute value of x is greater than some value a. Anytime you have the absolute value is less than, that's going to be an and compound inequality. And if you have greater than, that's going to be an or compound inequality. So the original original inequality for the absolute value tells you your types of solutions you're going to have. Our first example is the absolute value of x plus 2 is less than 5. So the original absolute value is in less than, so I know this is going to be an and. So my first inequality I'm going to solve is x plus 2 less than 5. But just like an absolute value equation, there has to be two inequalities I solve. So I keep the x plus 2 the same, but I'm going to flip the inequality and I'm going to change the sign of the value. So my second inequality is going to be x plus 2 is greater than negative 5. When I solve the first inequality, I'm going to subtract 2 from both sides. So we get x is less than 3. My second inequality, I'm still going to subtract 2 from both sides, but we end up with x is greater than negative 7. So because I know this is an and compound inequality, I know I'm going to write one interval. And in order to figure out the order, the smaller number has to go on the left side of the interval, and then greater number has to go on the right. So I know it's going to be negative 7, comma 3, because negative 7 is smaller than 3. And they're a strictly less than and a strictly greater than, which means both of these values are going to get parentheses. For an absolute value inequality, your parentheses and brackets have to match. So you're either going to have both parentheses or both brackets. You're not going to have a mixture. Our next example is the absolute value of y plus 2 is greater than or equal to 6. So because the original inequality is greater than or equal to, we know the solution is going to be or. My first inequality that I'm going to solve is y plus 2 is greater than or equal to 6. Similar to A, I'm going to keep the y plus 2 the same, but now I'm going to flip the inequality and I'm going to change the sign of my number. So I'm going to get y plus 2 less than or equal to negative 6. So I'm going to subtract 2 from both sides to get y is greater than or equal to 4. Then I'm going to subtract 2 from my other inequality, and I'm going to get y less than or equal to negative 8. So because this is an OR compound inequality, I'm going to write 2 intervals for my solution. And the way I'm going to write my solution is first I'm going to start with the less than or equal to inequality. You always want to start with the less than or equal to inequality when you write a compound solution. So everything less than or equal to negative 8 is going to be represented by negative infinity, comma, negative 8 with a bracket. Then we're going to do our union, so our U to represent OR. Now we're going to do everything greater than or equal to 4. So greater than or equal to, I'm going to start with my value, 4, and I'm going to go into infinity, and because the 4 is equal to, it's going to get a bracket. So both of our inequalities had equal to, so both of our values get brackets. Now we're going to take a look at Module 2, which is solving systems of equations. The first thing we want to do is solve a system of equations by graphing. So this is where you're going to want to use Desmos. If I graph both equations in Desmos, you should end up with a picture like this. The solution is going to be the point where they intersect. So in this case, the point where my 2 equations intersect is at 2, 0. Next, we want to look at solving a system of equations by elimination or substitution. And I'm going to do one of each. That way you see each of the different types, and that way you can choose which one you want to use on the exam. Or if you're specifically told a method to use, you have an example of each. Our first system is 3x plus 7y equals 19 and y equals 5 minus x. So this is a perfect example to do substitution. So what I'm going to do is I have one of my variables already isolated. I know y is equal to 5 minus x. So I'm going to substitute that equation into the first one for y. So we get 3x plus 7 times 5 minus x equals 19. Now I have an equation that only contains x that I can solve. So now I'm going to distribute the 7 into the parentheses. So we get 3x plus 35 minus 7x equals 19. When I combine like terms on the left, I'm going to get negative 4x plus 35 equals 19. My next step is to subtract 35 from both sides. You get negative 4x equals negative 16. Then we're going to divide both sides by negative 4, and we get x equals 4. Now that we know what x equals, we can easily plug it into our second equation to solve for y, since we know y is equal to 5 minus x. So y is going to equal 5 minus 4, which means y is going to equal 1. So you can leave your answer as x equals 4, y equals 1, or you can write it as a point, and when you write it as a point, you write it as x, comma, y. Next, we have the system 4x minus y equals 10, 5x plus 2y equals 6. This is an example I'm going to solve using elimination. So when we use elimination to solve a system of equations, we want to make sure the same variable in both equations has the same coefficient but opposite signs. In this system, if we look at our coefficients, the y's already have opposite signs, and it's going to be easy enough to multiply the first equation all by 2 to get them to both be a 2y. So once I multiply the entire first equation by 2, we're going to end up with 8x minus 2y equals 20. Our second equation isn't going to change. It's going to stay 5x plus 2y equals 6. We are now going to add our two equations together. And the y's are going to cancel, and we end up with 13x equals 26. Divide both sides by 13, and we end up with x equals 2. Now that I know x, I can plug it into one of the original equations to solve for y. I'm going to plug it into the second equation. So we're going to have 5 times 2 plus 2y equals 6. 5 times 2 is 10. We're going to subtract 10 from both sides, so we get 2y equals -4. Divide both sides by 2, and we end up with y equals -2. So similarly, you can leave your answer as x equals 2, y equals -2, or if you write it as a point, you get 2, -2. Again, written as x, comma, y. So number 6, we want to write a system of equations that represents our word problem and then find the solution. So our problem states that last year the volleyball team paid $5 per pair of socks and $17 per pair of shorts, spending a total of $327. If the team purchased a total of 27 items, how many of each did they purchase? So it's important that we pick out the information that's going to give us our system of equations. So $5 per pair of socks, $17 per pair of shorts for a total of $327. We also know that they got 27 items. Those items being a pair of socks and a pair of shorts. That's going to tell us what our two variables represent. So x is going to represent our number of pairs of socks, and y is going to equal our number of pairs of shorts. So when we set up our system, one of our equations has to represent the total amount of items purchased. So when we add our pairs of socks and our pairs of shorts together, we have to get 27. We also know the amount of money they spent per socks and shorts for a total amount of $327. So $5 per pair of socks plus the $17 per pair of shorts is going to give us the total spent $327. We now have a system of equations that we can solve using elimination. So we have an option. We can either eliminate x or we can eliminate y. It doesn't matter which variable we choose. I'm going to choose to eliminate x, so I'm going to multiply the first equation by -5. So when I do that, I end up with -5x minus 5y equals -135. My second equation doesn't change. It's still 15x 5x plus 17y equals 327. I'm going to add my two equations together. The x's are going to cancel. -5y plus 17y is going to give us 12y. -135 plus 327 is going to give us 192. We're going to divide both sides by 12, and we're going to get that y equals 16. Because we know that the total amount of socks and shorts purchased has to add to 27, we know x plus 16 equals 27. I can subtract 16 from both sides, and we'll get that x equals 11. So they purchased, if I want to write a sentence representing my solution, I can say 11 pairs of socks and 16 pairs of shorts. The last thing we're going to look at is how to solve a system of 3 equations. In order to solve a system of 3 equations, you want to make sure you follow the 3 steps. Okay. Step 1, we're going to eliminate one variable from 2 pairs of equations. In this case, the easiest variable to eliminate is going to be y. So look at the first 2 equations. I don't have to multiply by anything in order to eliminate y. And I only have to multiply once in order to eliminate using my third equation. So first I'm going to rewrite the first 2 equations. X plus y plus z equals -1, and 2x minus y plus 3z equals -5. I can now add those 2 equations together and the y's are going to cancel. So we end up with 3x plus 4z equals -6. Next, I want to eliminate y a second time using my third equation that I haven't used yet. So 3x plus 2y minus 5z equals 21, and I have to reuse one of the first 2. So because the y's in the second equation already have opposite signs, I'm going to be reusing my second equation. 2x minus y plus 3z equals -5. But in order for y to cancel, I have to multiply my second equation by 2. That's now going to give me 3x plus 2y minus 5z equals 21, and 4x minus 2y plus 6z equals -10. Still going to add the 2 equations together. The y's are going to cancel. Then I'm left with 7x plus z equals 11. We now have 2 equations that only have the variables x and z. That's going to lead us to step 2. So step 2 is to solve the system of equations from step 1. So my system is 3x plus 4z equals -6, and 7x plus z equals 11. So if I decide which variable I want to eliminate using elimination, it's going to be variable z, because it's easy to multiply that second equation by -4 in order for the z's to eliminate. So my first equation isn't going to change. It's going to stay 3x plus 4z equals -6. But my second equation, it's become -28x minus 4z equals -44. When we add our 2 equations together, the z's are going to cancel, and we end up with -25x equals -50. Now we're going to divide both sides by -25, and we're going to get x equals 2. Now that we know x, we can use that to solve for z, because I have two sets of equations that only contain x and z. So I'm going to go ahead and plug x into my second equation. So we're going to get 7 times 2 plus z equals 11. So that's going to become 14 plus z equals 11. We're going to subtract 14 and we get z equals -3. We have now solved for 2 of our 3 variables, and that leaves us step 3. So step 3 is going to be to plug in x and z into one of our original 3 equations to solve for y. And I'm going to use that first equation because it's just x plus y plus z. So I know x is 2. So we're going to have 2 plus y plus z, which is -3, equals -1. When we do 2 plus -3, we're going to get -1 plus y equals -1. We're then going to add 1 to both sides and get that y equals 0. So again, I can leave my answer as x equals 2, z equals -3, y equals 0, or I can write my solution as a point, 2, 0, -3, listing them in order, x, y, z. Let me know if you have any questions over the problems reviewing modules 1 and 2 for your midterm exam.